Hello, friends. We're continuing our study of precalculus, and we've reached the point where we're doing trigonometry, the unit circle, which is really just a study in order and unity here. So let's take a look at what we've got. We're thinking about, the unit circle. The whole idea is that it has a radius of unit 1. And so as we're looking at sine and cosine, so, cosine gives us the x coordinate, sine gives us the y coordinate. If it's, r cosine or r sine, r is 1. So it's just sine and cosine giving us the y and the x coordinates as we move around the circle here. And so, and that's corresponding to these angles, right? Whatever the angle is in here. And so we've got this tight relationship forming between the angle, the x coordinate, the y coordinate, and we're going to be, this is very useful application. So this is in the figure above shows a circle of radius 4 along with an equilateral triangle. Equilateral triangle. Um, and so it says, which of the following gives the coordinates of point Q? Well, if this is an equilateral triangle, think about that for a minute. That means that this angle here is 60 degrees, right? And so that means that this would also be 60, and this is also going to be 60 here. If this is 60, this is 30 degrees on either side of the vertical axis. And so that's 60 degrees. What is 60? This is pi over 3. If you think of this as pi, we've divided pi evenly into 3 spots, right? And it has a radius of 4. So it says, which of the following gives the coordinate of Q? Well, Q is going to be the same as P, except it's just going to have a negative x coordinate, right? And so, so this is going to be cosine, so negative 4r cosine of, I guess it would be 2 pi, or positive 2 pi over 3, because it's 2/3 of the way around. It's going to be the same as negative, if we had cosine of pi over 3 and made that negative, that would be the same thing as what we get here. You could try that, put it in a calculator, right? Cosine of pi over 3 and then cosine of 2 pi over 3. It should just give you the negative value of that. And then for sine of 2 pi over 3. Okay, so that's going to be answer C. Yes, got it right. Okay, here's another example. It says we have a circle of radius r, line y equals negative x. It says the circle and the line y equals negative x intersect at points r, o, and p. I guess you could say the circle intersects at o. Right, so that's the center. If the coordinates of point P are 6 root 2 and negative 6 root 2, what is the value of r? So this is 6 root 2 and negative 6 root 2. Those are those coordinates. Well, the coordinates are going to be the same for r, except that the negatives are just going to be switched. This is here, this is 45 degrees. This is 45 degrees. It's just reflected across. And we can tell it's 45 degrees because notice that the magnitude is the same, 6 root 2, 6 root 2. That's the magnitude. The negative is added onto that. So we have a negative x coordinate, negative 6 root 2 here, and a positive y coordinate, 6 root 2, because we're in the second quadrant. And that'll give us the coordinates for r. Oh, but they want to know what is the value of r. So I gave you a lot of explanation and not quite the right explanation. So we saw from the previous unit that, so what we can do is we can look at, I'm jumping ahead of myself. We can treat this as a right triangle, and this is 6 root 2, negative 6 root 2, and this is 6 root 2. So I can use the Pythagorean theorem to figure this out. And it's actually, it feels like it's going to get really messy, but it's actually not. So 6 root 2 squared plus 6 root 2 squared equals r squared. Right, well, 6 times root 2 squared, so that's 36 times 2. So what is that? 72? 72 plus 72 equals r squared. So 72 plus 72 is 144. equals r squared. So r is equal to 12. We're going to find shortcuts for doing this in a little bit too that you'll see. Because notice now that when I have that angle, the coordinates are, it's like I take 12 and I multiply by the square root of 2 divided by 2. Say 12 times square root of 2 divided by 2, then I get 6 root 2. And then the negatives, depending on the quadrant that I'm in, putting the negatives in there. Let's take a look at this one. So we're considering these points. Find the values of the following. So cosine of 0, you can try this in your calculator too to see how it all lines up. Don't forget to put your calculator in radian mode. The cosine of 0, the x-coordinate of 0 is 1. I have a radius of 1 there. Cosine of pi over 2, well, yeah, so let's do the sine and cosine together. So sine is the y-coordinate. Well, the y-coordinate here at this point is 0. Cosine of pi over 2 is 90 degrees, in degrees at least, so that's this. Here the x-coordinate is 0, but the y-coordinate is 1. This is 1. At cosine of pi, so the x-coordinate here is -1, y-coordinate is 0, so -1 and 0. And then 3 pi over 2, that's down here, 270 degrees. Y-coordinate or x-coordinate is 0, y-coordinate is -1. I mean, the coordinates are there, right? They're giving them to us. So we're starting to make sense, give some numbers to these things. We're going to keep track of these and put them all together. In the end, you'll see there's this beautiful pattern, the way it all plays out. And so we're going to start doing now is putting in actual values for when we find sine and cosine. Instead of writing like, r sine theta, we can find for some very common angles, angles like 30, 45, 60 degrees, we're going to see this pattern that shows up. And so, for example, here for this one, we're going to use ideas from 3.2. Now we're in 3.3 to put this together. So we've got this unit circle, and there's an equilateral triangle here. Here's this equilateral triangle. So because this is an equilateral triangle, I know that this is 30, and this is 30. And I know then that the x-axis cuts this line in half. But I know that the length of this whole thing is 1 because it's an equilateral triangle. So then half of it, it's 1/2. So the y-coordinate is 1/2. To find the x-coordinate now, I can use the Pythagorean theorem. Right? I know that 1/2 squared plus, I'm going to put x here since it's the x-coordinate, x squared equals 1 squared. So let's see, what do we end up with here? We end up with, so this is, 1/4 plus x squared equals 1. So x squared equals, now I have 1 minus 1/4. So this ends up being 3/4. And so x equals the square root of 3/4. And so this ends up being the square root of 3 over 2. So this is root 3 over 2. Now I can use symmetry to know that the coordinates down here are also root 3 over 2. It's the same x-coordinate, but the y-coordinate is -1/2. Okay, so we're starting to fill out some of these x and y coordinates and the values. So let's take a look at the next example where we've got some of these, right? So again, what is theta here? So when theta is 30 degrees, actually, we're going to call this pi over 6. It's pi over 6. Pi over 6 radians, 30 degrees. And so we can use symmetry for these other points, Q, R, and S. So Q and R, so we got pi over 6, then we have 5 pi over 6, and then we have R is going to be 7 pi over 6, and this is going to be 11 pi over 6. Okay, so the coordinates for Q will be negative x but positive y, so negative root 3 over 2 comma 1 half. R is going to both negative, third quadrant, so both negative x and negative y coordinates. And then for S, positive x, but negative y coordinate. Okay. So just by figuring out that 1 point's coordinates, now I know 4 points in there. And actually, if we take this diagram that we have and we just turn the whole thing, then we end up with example 6. So I'm going to skip to this one, right? Because now by making it vertical, so if this angle theta is 60 degrees, or again, pi over 3, then I know this is 60. So I've got this equilateral triangle. And again, this is 1 half. But look now, that's the x coordinate, right? And the vertical coordinate then is root 3 over 2. And so, yeah, I know I'm going to go back to example 5. I know. Calm down. Relax. We're going to get there. So these angles, I've got pi over 3, 2 pi over 3, 3 pi over 3 would just be pi. Then I've got 4 pi over 3, 5 pi over 3, and then 6 pi over 3 would just be 2 pi back where I started on the positive x-axis. So again, the coordinates, it's the same set of coordinates, just manipulate the negative and the positive to get into the right quadrant. So it'd be negative 1 half for Q. It's in the second quadrant, so negative x, positive y, 3 over 2. And then negative 1 half and negative root 3 over 2. I'm in the third quadrant, so both are negative. Now, point S, fourth quadrant, so I've got positive x and negative y. All right, so I've got a bunch of points now that we can assign values to for the x and the y coordinates if it is a unit circle. If it's not a unit circle, you just take the value of the unit circle and multiply it by the radius, whatever that would be. Let's go back now to example 5. And here, if we've split this up halfway, so these are 45-degree angles. We call this pi over 4 in radians. And if we use Pythagorean theorem, right, then we know that the x and the y are the same. So it ends up being, x squared plus y squared, but it's really just x squared plus x squared. Solve it, 2x squared equals 1. Solve it, and we get plus or minus 1 over root 2, but we simplify that, right? We don't like having square roots in the denominator. So this ends up being root 2 over 2. And that's the same x and y coordinate. It's a 45-degree angle, an equilateral right triangle. No, sorry, isosceles right triangle. We've got pi over 4. 2 pi over 4 would just be pi over 2, which is what we have before, 90 degrees. But then we're going to have 3 pi over 4. And then 4 pi over 4, 5 pi over 4. 6 pi over 4 would be, 2 pi over 3, or 3 pi over 2. And so then we're going to have 7 pi over 4 back into the y coordinate, the fourth quadrant, sorry. And so it's all root 2 over 2. I'm just going to do this and then fill in the positives and negatives afterwards. 2 over 2, root 2 over 2. Okay, point Q, second quadrant, negative x, positive y. Point R, third quadrant, negative x, negative y. And then point S, fourth quadrant, positive x, negative y. Okay, we've done a bunch of work. We've gotten a lot of different angles, a lot of different x and y coordinates. And so now we're going to fill this in, this thing. Actually, it's filled in for us. This is the unit circle. We have the angles in here, right? So this line represents the angle pi over 6. This line represents the angle pi over 3, just like we did before. This was part of the last lesson. And now we've got all these coordinates, 1, 0. Now look at the pattern. They're all over 2, 1 over 2, root 3 over 2. But so take a look at the x, or at the y coordinates, right? So what's happening here, as this goes higher, the y coordinates are going to be increasing. First it's 1 over 2, then it's root 2 over 2, then it's root 3 over 2. You could kind of think about it this way, that they're all roots, right? This is root 1, that's not here, right? Root 1 over 2. So root 1 over 2, root 2 over 2, and root 3 over 2. This goes up. The x-coordinates, well, the x-coordinates are decreasing, right? First it's here, then it's here, then it's here. And so we're starting with the biggest, root 3 over 2, root 2 over 2, root 1 over 2. Again, the root 1 over 2 is just 1 over 2. And so the pattern continues. So it's these same coordinates, except over here, and you have negative x. So again, this looks like a lot. It's like, whoa, all these angles, right? And the coordinates, but it's the same pattern. It just repeats itself around the full circle. Okay. So it's really a thing of beauty. And there's really only a handful of things you need to memorize, and then remember what this pattern is of how you get around the circle. And so here's the unit circle. They want you to memorize. These are the points you need to memorize, really, basically, right? And then everything else is just a multiple of this or multiplying by -1. So here's some. It says find the values of the following expressions. So sine of 2 pi over 3. Okay, well, where's 2 pi over 3? First of all, it's less than pi, so that means you're in the top quadrants 1 or 2. 2 pi over 3, that's going to be over here, and sine is the y coordinate. So what's the y coordinate here? Well, as I'm thinking about this, I know that here I'm at the higher of the y coordinates, so it's going to be root, and it's positive, so root 3 over 2. Just check my answers so I don't lead you astray as I go along here. Cosine of 5 pi over 4. Okay, well, 4 pi over 4 would be right over here. So 5 pi over 4 is going to be right here. And so it's going to be pi over 2 cosine. So it's negative, because I'm in the third quadrant, negative x coordinate or y coordinate. Either way, for the pi over 4, it's the same. But this is going to be negative root 2 over 2. 11 pi over 6. Okay, so that's 1/6 less than 2 pi, or yeah, 1/6 less than 2 pi. So actually I'm here, and I'm moving 1/6 pi this way. So that's taking me to here. Cosine, so it's the x coordinate. Notice that I'm as far to the right as I can get without actually being here at 1 comma 0. And so the x coordinate here is going to be positive 3 pi over 2. Or rather, sorry, root 3 over 2. Okay, D, how many of these are? It's a bunch. Wow. So D, 7 pi over 4. Again, I'm in this same quadrant over here, and it's asking for sine, which is negative. So that's important to pay attention to. Negative sine here is negative root 2 over 2. Cosine of 4 pi over 3. So that's 1/3 past pi. Here's pi. 1/3 past is here. And so this is going to be, it's asking for cosine, so negative 1/2. Okay, and then 7 pi over 6, that's 1/6 past. So I'm in that same quadrant, quadrant 3, and it's asking for the sine. So sine of this angle is negative 1/2 also. Okay, cosine of pi. Well, pi is here, and cosine, I can see the x coordinates right there, so it's -1. Sine of 3 pi over 2. 3 pi over 2 is here, and sine is the y coordinate, which is -1. Cosine of 2 pi over 3. Uh, so 2 pi over 3, so that's 2/3 of the way around at the top. That's over here. And it's asking for cosine of that. So cosine is the x coordinate. It's the first here, right? It's like the smallest x coordinate of these three. And so that's negative, and it's negative because it's on the left side. So negative 1/2. Okay, almost done. Cosine of 5 pi over 3. So 5 pi over 3 is almost 6 pi over 3, which would be 2. So I'm I'm 2/3 away around there, but I'm 1/3 from the end, you could say. So that's over here. And this is asking for cosine. So it's the x coordinate. I'm on the positive side, and it's kind of going outward. It's the first one that I hit, right, the small x coordinate. So that is positive 1/2. Okay, sine of 0. Well, at 0 degrees or 0 radians, that's the same for both, I'm here at this point, and so sine is 0. It has no height at that point. So equals 0. And then cosine of pi over 2 is 90 degrees straight up. And at that point, the x coordinate is 0. Okay. So we've done a lot of practice. We've put this whole thing together, right? The angles using Pythagorean theorem, the unit circle. But again, it's just a few things, and there's this pattern to it. So you remember those few things, and you remember the pattern, and it's beautiful, right? Harmony, order, all over the place. So enjoy if you can. I know it's tedious at first when you're learning it, but it really is fantastic, and we use it a lot. I use it on a regular basis in my AP Physics C class, and we're going to be digging into this and using it quite a bit. So learn it, just practice with it, and we'll see you for the next lesson. Thanks for watching. Don't forget to like and subscribe.